Okay, so first I'm gonna show you the units for what we're gonna be learning because units are very important. Without units, it could be whatever. So first we're gonna start with distance, which is also known as a delta x. Now the units for delta x slash distance is meters. Are you taking notes?
Sorry.
Okay.
The delta x. That's the little triangle thing, right?
Yes, triangle with x.
Delta x. Cool. You said meters?
Yes.
Okay.
Alright, so next is velocity, which the units for that is meters per second. Velocity. You can just write a big V for velocity.
Alright, equals, and then meters per second. Can I put MPS or?
Just put meters slash or m slash s like I put here.
Right there.
Okay. So then you have time, and the units for that are just seconds or an s.
Alright.
And in this case, in physics, time will always be in seconds. So if you were given a problem where it is in minutes, you need to convert it into seconds. Okay? I'll show you how to do that later, but it's pretty simple. Okay, the next thing we're gonna learn is average velocity. And I'm gonna show you what it all means when you are later given a graph and how to convert that into an average velocity formula.
Yeah.
Okay, so the formula for that is just V, which is velocity.
Yeah, velocity.
Which is equal to delta x distance.
That's the triangle.
Yes. Delta x over delta t, which is distance over time. So delta t. Okay? Any questions? You seem lost.
Yeah, the whole like delta triangle thing is, I don't know, it kind of confuses me. I'll get the
It's
hang of it.
time. I mean, it's distance. Delta x is delta.
Yeah, I was just, it's just, you know.
Okay, and then that's not it. That's the only thing you're gonna write down. So then it's gonna be delta x over delta t equals x final.
What, hold up.
Which is distance final, position final.
Yeah.
Over x initial.
Over xi.
No, not over xi. It's x final minus x initial.
You said over. X initial. Alright.
Okay. And then that's gonna be on the numerator. On the denominator part of this, it's gonna be t final minus t initial, which is time final minus time initial. So the final part will be the time and then starting point, which is initial.
Alright.
Okay, now it will all equal out to an answer depending on the numbers that you are plugging into it. And it will always end in meters per second because that is the unit for velocity. And this is the formula for average velocity. Okay? You good?
Yeah.
Any questions?
Nah. Oh, like, I don't understand. Oh, wait. Nah, I don't get how we, like, oh, wait, I think you're getting to that, though. I don't want to, like, cut you off, like,
Yeah.
because I don't understand this so far.
Yeah, like, I'm just giving out the basics, and then I'll show you, like, what we use this for.
Alright, so it's normal not to know this right now.
Well, yeah, but, like, you're gonna need to know these.
Alright, like, memorize them, or, like?
No, I'll write them down for you.
Alright,
like,
thank
for
you.
the test and everything.
Okay.
Okay, then the next thing is displacement, which is the area under the curve. Displacement. Area under the curve. Okay. If you are giving a graph where there is a triangle present, the displacement formula for that is just velocity times time times 0.5. Because it's the area, basically, for that.
Alright, so, wait, you said what?
Triangle.
Triangle?
If the graph is in triangular form, the part that you're trying to figure out,
Yeah.
then it is velocity times time times 0.5, or 1/2.
Alright.
Okay?
Yep.
If it is in the square form, then it's just simply velocity times time.
Square equals velocity times time. There we
Okay?
go.
And then we're going to move on to the mathematical model part, which is MM. I call it MM. Okay?
Alright, hold up. Let me
So, the mathematical model part is y equals mx plus b.
Whoops.
But y equals mx plus b is used in like algebra or geometry
Yeah,
or
I
whatever.
use it in geometry.
Yeah. So we're not going to use that because it's physics. So we are going to turn that into x equals velocity times time plus 0.
Velocity times time plus 0?
Plus 0, yes. Okay. So that's the math model. Alright, now I'm going to show you why or how you're going to use these in a question or no problem. Okay, so let me write this little small graph.
Hold on, I'm writing the formula. Yeah, I probably shouldn't be writing all this out. That's right though, right? Mx plus b and then x equals velocity times time plus 0?
Yes, plus 0.
Alright.
Okay.
Gotcha.
So, in this graph, I'm going to write, this is called a velocity time graph. So, velocity is on the y-axis.
Well, you want me to copy that down?
No, I'm going to have it around this paper.
Alright.
And then time is on the x-axis, which time is in seconds, and velocity is meters per second. Okay?
Okay.
Excuse me, I'm very tired.
Yeah, it's okay.
Okay, so I'm just gonna draw out a graph for you, and I'm gonna show you how
To fill it out?
Yeah, how we would use average velocity, or how we would find average velocity using the graph, displacement finding the graph, and write a mathematical model.
Mm-hmm.
Okay, so let's say this is in 5, 10, 15, and right here is in 2, so 2, 4, 6, 8. Okay, let's say the graph looks something like this. Okay, so to find average velocity, you use that big formula, which is v equals delta x over delta t. Always write out your original formula. Yeah.
All right.
Which equals x final minus x initial over t final minus t initial. Okay.
Mhm.
So that's gonna be equal to delta x. So x final.
Yeah.
Is figured out to right here. So anything that's in final form was right here, because this is where this is where the graph would end, or where the line ends.
Okay.
Now, initial is the starting point.
Oh, like the initial place from where it started, correct?
Yes.
All right.
So it's right here. Now, to find x final and x initial, you would look on this part of the graph, because this is where velocity is.
So the y-axis?
Yes. Okay. And so this would be 15, because it's right here.
Oh, and it stops at the top of the 15.
Yeah. 15. And then this goes for x initial, which is right here, because this is where it started.
So that's 0?
Yes, 0. So 15 minus 0.
Alright.
Okay. And now we do the same thing for time, except we don't look on the vertical graph, we look at the horizontal graph.
So you don't look at this at all. You just look at what's down here, and then the line, of course? Or?
For the top part, you look at the vertical.
And then for the
bottom part is horizontal, because where time is, where delta t is.
Oh, so the bottom's just finding the time, right? Or
yes, and then the top is finding the distance.
Alright.
Delta x.
Alright.
So this one right here, it ends at 8. You see how I got that?
Yeah, because the 8's the line, or it's where the line stops, correct?
Yes. And then
0, because that's the initial start.
Yeah, you got it. So then that would just be 15 minus 8. 15 over 8. Yes, 15 over 8. And that would be your answer, but you cannot forget units. So 15 over 8
meters per second,
yes,
right?
Meters per second.
Alright.
Okay, that is how you find average velocity.
I don't know why I keep
Now using the same graph, we are going to find displacement.
Displacement. I gotta look at the... Wait, but is this a triangle or a square? Because it looks like...
It's a triangle.
Oh.
If you're finding this part,
yeah.
right here, triangle.
Alright.
So, let's say we're finding just this. I'm only going to do like one for displacement, and then I'll do one for math model.
Alright.
Yeah, basically.
Okay.
So for displacement, since it's right here, we're doing this part, it is a triangle. So it is v times t times 1/2, which is equal to the velocity would be, in this case, we're going to say this is right here, so we're going to put 5. Okay?
Alright, yeah, I got
So that's
that.
velocity, so 5, times time, which is 2 seconds. So times 2, times 1/2, which will equal 5 meters.
5? Yeah.
Do you see how I got that? Because
Yeah,
5
5
times 2,
2.
10 times 0.5.
Yeah, and the displacement it's just in meters, no per second,
Yes.
none of that?
No,
Alright.
displacement in meters. And then velocity is just meters per second.
Alright.
Okay?
Uh-huh.
So now we're going to write out a mathematical model. I like to call it. Now,
Wait, do I copy this part down? Or?
no, I'm going to show you how to do it all.
Okay.
Okay.
Mm-hmm.
So for the mathematical model part, in order to even start to like write out the mathematical model part, you first need to find average velocity. So average velocity should come first before finding a mathematical model. Okay, so the formula for that equals x equals velocity times time plus 0. Okay, in this case, x will remain x. The v, since we found velocity, is 15/8.
Oh, you just plug it in?
Yes. And then time, we haven't been given a certain time yet. You will be asked a question where it is asking to find the mathematical model using a certain time, like 8 or some.
Oh, so it's sometimes given.
Yeah, sometimes given.
Alright.
But if it's not given,
you gotta find it.
or if it's not given or it's not asked to be found, just put t.
Alright.
And then in this case, it's not always gonna be plus 0 because this is like the starting point. So in this case, it is 0 because we start at 0.
Oh, so that last one's the starting point.
Yeah, but if you started at like maybe like 8 or 5 or something, it'd be plus 5 or plus 8. It depends where the graph starts from.
Yeah.
In this case, it's 0, so plus 0, but it's not always going to be 0.
Alright.
So we found average velocity, displacement, and the mathematical model in this formula right here. Okay, so now we're gonna see if you paid attention, and I'm going to give you a graph, and I'm gonna ask you to find average velocity, displacement, and mathematical model.
Alright.
Or write out mathematical. Okay. Okay. So
Can I use my notes or?
yeah, use your notes.
Alright.
I'm gonna make this. So velocity and time. Okay.
Is that it or? You done?
Yeah.
Alright, let's see.
Using this formula for average velocity, find the average velocity for this.
The average velocity? Well, that's this one, right?
Yeah, this is the formula for average velocity.
So, average velocity.
Oh, sorry.
So it'd be 10 then? Or no, wait, no. It starts at, yeah, the initial start, correct? Or?
You start with final first. Write out the original formula first, so that helps you out a lot.
Alright, so x, f, and then x, I. It's subtracting, right?
Yes. Over.
Subtracting over, and then it's t final minus t initial, right?
Yes. But you need to write out this part too, because this part's also starts with the delta x and delta t.
Delta.
It may not seem important, but you should always write it out when writing up the formula.
Delta t. Alright, so now I just plug them in.
Yes, so what do you have for x final?
The final is at 25.
Yes.
So 25 minus initial, so 10?
Yeah, so you started at 10.
Alright. And then t final, so that's 5, right? Because this is the last one.
Yes.
5 minus, and then the initial on this axis, correct? Or because it stops right here, so 0, right?
Yes.
Alright, so then, and then do we simplify it to?
Yeah, you just simplify it. Always simplify.
Right? Is that correct?
Yes.
Because 5 goes into 50 times. And then, is it meters per second or just meters?
Meters per second because it's velocity.
Oh, okay. So is that good?
Yeah, you did it right. Okay.
Now I gotta find the
displacement,
right?
Mm-hmm.
Do you want me to write down this equation too, or?
Yeah, always write out the original equation. Always.
Right, so
It helps you out a lot. So you know what to substitute in for.
So then the velocity that we just found was this, correct? Or
No.
no? Oh yeah, isn't that average velocity? And then
Displacement for this
yeah.
is the area under the curve. So we're gonna be looking at this part right here. Okay.
Oh, I'm sorry.
Mhm.
So
That 10.
mhm.
So velocity is 10.
10 and then times time, which would be 1, right?
1 in this case.
Oh, I put plus on accident. times 1. And then that
Times 1/2.
oh, times 1/2. Times 1 is 5?
Yes. With units.
5 meters. Is it meters per second or meters?
Meters.
Meters. Thank you.
Mm-hmm.
And then that's the answer for that? Or is it? That's for displacement, correct? And then the math model, you just plug it in and then plus the initial start, correct?
Yes.
Alright.
So, what's the mathematical model?
X equals V times T plus Z, well, the start, right? So the velocity is 10, correct?
No. Velocity is found right here. Average.
Oh, that's the average. Oh,
yeah. And so in displacement, you wouldn't use this.
At all? You just find the start, right? Or, well. Oh, okay, I'm sorry.
Yeah, displacement is its own thing. It doesn't have to do with this. But like, for the mathematical model, you would need to use average velocity to find out the big V.
Oh, okay. So we're talking about this, right? The math model?
Yes, this is the mathematical model.
And then time. Did it give us the time or?
No, in this case, not giving you the time.
Alright, so T.
So yeah, times T.
And then plus. It's where the start is, so 10?
Yes, because in this case we start at 10.
Alright. And is that it, or do I have to like solve it? Or?
That's it.
Okay.
When I say mathematical model, you just give me this. You don't need to solve it. Just give me that flat out.
Okay, so do I do the mathematical model before I do the displacement then? Because if that...
Depends on how the question is given to you. Like question 1 would be like, oh, average velocity. Question 2, displacement. Question 3, math model. But
oh, yeah.
you'll always need to use average velocity for your mathematical model.
Okay, so I
that's
just gotta
what the big V
remember this.
represents.
Yeah. Oh, I messed up. They're on this side, so I should have just...
Yeah.
Yeah, that's my fault.
That's okay. Alright, now let me look at my lesson plan real quick. What we'll be doing next. Okay. I got that all on one page. I didn't have to use 2 pages. I thought I would. Good job. Okay. So I told you about this graph.
Yeah.
Which is velocity time time graph. Now we need to learn a whole new graph, which is called a precision time graph. Okay?
Mm-hmm.
So that's gonna look, yeah, let me draw it out for you. It's gonna look something like this. So this is still time.
Uh-huh.
So horizontal is still time, and it's always going to be in seconds. And then position.
Position? It's not velocity?
What's called precision time graph.
Oh, my
It's
bad.
gonna be, yeah, I know that. Yeah. Okay.
Oh, so is that still meter per second? Alright.
Okay. So it's gonna be 0 because this is where the time is.
Mm-hmm.
0's in the middle. Then we'll put 1, 2, 3, -1, -2, -3. That's how a position time graph will look. Okay.
Like always?
Yes.
Okay.
Okay.
Mm-hmm.
Now I'm gonna show you how you would find displacement for this type of graph.
Okay.
Okay.
Can I take the notes for this one, or we're doing it on this paper?
You just go off of what I have on this paper.
Alright.
So I'll let you keep this paper. So you can like study for the quiz or whatever. Okay, so then it will be, I'm gonna write it out like for the first time. So 1, 2, we'll start off a little simple.
Wait, so the line that cuts through is always going to be the time? Like the one that's on the x-axis?
Yes,
It's always time?
time. So let's see, this right here. And then we'll put this right here. And then we'll put this right here. Then it'll be part A, part B, part C. Okay?
Yeah.
Now we'll talk about displacement for this one. So for A, displacement, since this is obviously not a triangle and is like a square or a rectangle,
Yeah.
is displacement for this is gonna be velocity times time.
Okay. Can I write that down?
You have it written down right here.
Oh yeah, for square, my bad.
Yeah. Okay. And so, I'm tired.
It's okay.
Okay. And so for this, for part A, the velocity is 1. And then the time is 1 because it only took 1 second for that.
Is that just how many jumps it makes? Like from,
Yeah, one jump.
Because it starts at 0 and then it goes to 1, so that's just one jump and then you put it?
Yeah.
Alright.
So 1 times 1, 1. Simple. So B.
But that's below it. What do you do here?
It's a negative. So since it's negative, you'll do the same thing except it's a negative number.
Alright.
So for this one, it will be, oh, I'm sorry, and this also in meters.
Okay.
So it's displacement.
Yeah.
Okay. And so for part B, it's gonna be -2 times the time, which only took 1 second jump, because from 1 to 2, so 1 jump.
But if there was more, it'd be like, you just count the jumps, how many makes?
Yeah, so if like this was like spread out from like here to here, then it would be 2 jumps. So it would be times 2 instead of times 1.
Alright.
So this is -2 meters. Okay. Part C is up here. So it is at 3. So it's 3 times, it's 1 jump, so it's 1.
One jump. I'm sorry. Hey, look. 1, 2, 3.
Oh. Yeah. Okay. So, well, -2.
Oh, yeah.
But yeah. Okay. So, let me see here. Okay. Now we will be turning this graph, our position time graph, and we will be writing out a velocity time graph. Okay. So, it's okay. It's not that hard. Okay, so I'm sorry. I'm like getting hurt.
Yeah.
So this is our graph.
Yeah.
Okay. And for this, you will be having to write out this by yourself. But I'm gonna show you how to do it.
So would this be position or would it be
velocity? Because it's a velocity time graph.
Oh, we're changing this into this, correct?
Yes.
Alright.
So and like to help you remember like which one's which one. Like think about velocity as a V, right? And a V goes like that.
Yeah.
And these types of graphs go like that.
Oh, wait.
So that's how I remember it. Yeah. Go.
You mean like here?
Yes.
Oh, okay. I'm sorry.
It's fine. But like it'll go like that basically.
Alright.
And position time graphs is just like the time and then the positions that could be different.
So position square velocity triangle, right?
Basically, yes.
Oh, so I can think of the V as like a little, like the triangle. Alright, I got that.
Whatever help. Okay.
Flip you, bro.
Yeah. Okay, so let me look at my plan. I thought it was very darling. Okay, so I will give you the seconds, which is 0, 1, 2, 3, 4, 5.
So the bottom's always time, it never changes at all. Like it's just
horizontal line, time.
always. Alright.
Okay. Now we need to convert this into this. So we use displacement to convert a position time graph to a velocity time graph. Okay. So this is 1 meter. This is -2 meters. This is 3 meters. Since we have a negative, obviously this right here can start off as 0.
It's gonna go down, right? Or
Yes. So unlike this graph right here,
which
where
side
like
is 0?
this is 0 for both, like the
Sides,
velocity and the time.
Yeah.
This one's not gonna be 0 for both the velocity and the time.
Oh.
Okay.
I got it.
Unless
Order.
given otherwise, like, hey, this is 0, it will stay 0. Then yeah. But like.
Oh, but there's a negative, so it can't stay 0.
Yeah. So we're gonna start off with right here -3. Actually, no, that's not how we're gonna do it. No. We're just gonna make it go below the graph.
Oh, like this one, where it went down, or?
Yes, but we're not gonna write out these numbers on here.
Oh, alright.
Okay. So we're gonna write this down as we're gonna count in ones. This is a 0, 1, 2, 3, 4. I will when I give you your quiz or test you need to take, I'm gonna give you this part, like the numbers for the time, but I'm not gonna give you this. No, you need to solve this by yourself.
Alright.
Okay. So since this goes up 1 meter, like as it's given right here in A.
Yeah. Does that mean you start there, or?
No, that means you go up 1.
Oh.
So go like this, for right here. So from 0 and go like this. So it's 1, 1.
Oh, so it has to be even to both of them? Like.
Because this is 1 times 1, it's 1 over 1.
Oh, okay, I'm sorry.
Okay, so it'd be 1 meter.
Yeah.
Now this one's gonna go down -2 because it's -2 meters. And that also, since it took only like 2 seconds, like, you know what I mean? Like, it's
oh yeah, from here to here. It's 2.
Yeah, so 2.
Yeah.
So it's only gonna be from right here to right here, but it's gonna go down -2. So it won't be 0. It'll be -1.
Oh.
So -1 will be right here. So basically, it'll be right here. But this is like 2.
Oh, so you basically plug this in, right? Cause no.
Yeah. You're getting right. Yeah.
Oh, okay.
Okay.
No, cause this is -2 times 1, so I just figured I'm confused.
Yeah, you go negative. You go -2 to -2 for 1 second.
Oh yeah, I get it now. So you go down 2 and then
For 1
from here, then go 1.
Yeah.
Alright, I got you.
Okay. Then this will be 3 meters going up for 1 second.
So would this one be at 2 seconds, but on the 3?
1, 2. No, it'll be You said 2 seconds, right? Or 2 meters, right?
Yeah.
Yeah, it'll be at 2 meters, but for the 3rd second. So it'll be right here.
And then you just connect it?
Yeah, you connect it. And that's how your velocity. I don't know if it look like. Okay. Oh my god.
Yeah.
Look how big ears.
Good teacher.
Okay. So that's how you convert this to this.
Alright.
Now I'm going to give you. Wait, do you have any questions?
Nah, you.
Like, I'll help you out with like the part I'm gonna give you right now, but like.
You actually I'm fine.
Okay.
That pretty well. I just got confused because like, so this has nothing to do with it at all. Like this really doesn't matter. You just need these two, or.
Well, like if like you get a question like, what is the displacement for this? You won't be needing to write this down from this, but you will need to use basically this part to figure out
This.
Yeah.
Oh, so this is just for graphing it, but that's for displacement, right?
Yes. But it's not always going to be 1, 2, 3, 4, 1, 2, 3, 4. Like, it'll be given like 5, 10, 15, 20s, and then you'll need to like multiply it, and then like this graph won't be 1, 2, 3, 4. Like.
So it just depends on the jumps, like from
Yes.
on this graph, not on this one, on this one.
Yes, because you get this graph from this graph.
All right. So you can create the velocity or the positioning graph. Is that what it's called? Like.
This is a position time graph, and this is a velocity time graph.
All right.
So you get the velocity time graph from the position time graph.
All right.
Okay, let's get it. So now I'm gonna write you. So now I'm gonna write you a graph,
Okay.
and I'm gonna have you do this. But of course, you ask me questions because I'm here to help.
So wait, are you gonna make the position time graph, and then I have to make the velocity graph? All right.
Yeah, you can just like, there you go. So this will be position time graph. This will be velocity time graph.
All right. Thank you.
So 0. So pause. Period. Okay, so -2, -4, -6. So then 1, 2, 3.
Oh, the sounds always positive.
Yeah, time was positive.
Thank you. This doesn't always have to be the same as this, right? Like, oh wait, no, this is 6 and this is 8. My bad. I confused it. My bad.
Just for this graph, because like I want to give you 1, 2, 3, 4, because that's like really easy. So I'm gonna give you like 2s and like stuff like that. That way, like it helps you prepare better for the quiz stuff I'm giving you.
Okay.
Okay, so we're gonna make this look like that. Make it go a little like this.
Wait, do those two like always have to connect from the end of this one to the beginning of this one?
What do you mean?
Like, you know how like this one starts here at 2 and ends at a 4, correct?
No, because
But this one starts at 4.
like I said, it's position time graph. So for, I'm trying to give you like maybe like a scenario where it would be like this. So like, let's say you were at 2 meters for 4 seconds. Then something happened where you were like.
Slow down? Like, oh wait, no, velocity. I'm thinking about something else, never mind.
Okay. Yeah, so like basically like let's say like you were 2 meters away from your house
Yeah.
For 4 seconds. Means you were driving very fast.
Mm-hmm.
But 2 meters away from your house for 4 seconds. Okay? But then you had to go back because you forgot something. But it wasn't at your house. It was like at a friend's house who lived a little farther. So you went from here to there, and then from here all the way over here.
Oh, alright.
Okay, so that's where the -6 will come from this graph. And then you went back to your daily routine and went from a negative to a positive again.
Mm-hmm.
So that's basically like the best I can do for a scenario for you.
That's fine. I understand it. You put it perfectly, so.
Okay, so find displacement for this right now.
The displacement, right? That's this, right? This.
Yes, displacement.
Okay, so this is one over one. So
Right down right here.
right here?
Mm-hmm.
Alright, so it starts right here at 2 and then goes to 4. So it jumps 4 times, right?
So
So
2.
it starts at 2 and then jumps 4 times. Is that good?
Mm-hmm.
And then 2, 8. Okay, now we do B.
Meters, not meters, but units.
Yeah, my bad. You just gave me the unit.
I know, I'm tired.
B. Okay, so it starts at. Oh wait, no. It starts at -6, and then it jumps 2 times.
No. What are you doing?
Oh wait, no. Oh yeah, this one. My bad. Okay, still jumps 2 units. It starts at 4 and goes to 6. So 2 units and -6 times 2. Negative. Right? Or is that good or?
-6 times 2 is in 3.
I didn't put 3.
That's a 3.
Leave me alone.
Here, you can use your calculator if you need it.
Is that good?
Yes, -12 meters.
I'm not good at like multiplication tables. I don't know why. Okay, so this will be the third one, right?
Yes.
Alright, so it's on the 0, correct?
I probably should have realized what frequency. Sorry. A, B, and C.
It's on 0, but it jumps twice. But that's still gonna equal 0.
Yes.
So now, do we want me to make this table? Oh, you gotta give me the time though, right?
Mm-hmm. What? Oh, no, I'm doing it right. I'm stupid.
Is it still gonna be like this where it goes underneath the line, like the timeline?
No, because this is a different graph. This is a velocity time graph and this is position time graph.
Oh, okay. No, I thought it was gonna be like this where it goes underneath.
Oh, baby. Yeah, I thought you meant
this
like this line was gonna be here still.
No, because this is a negative right here, -12, so it's gonna have to go down to like here.
Well, depending on how you do the units right here, or just the
Wait, yeah.
right here. But yeah. So let's see. Here's some 0. These two will be the same.
Okay, so time will be the same. That's
Yes,
okay.
but right here it will be different.
Okay.
I mean, it can be the same, but it'll be a very large graph.
Huge.
Yes. Alright.
Okay, so now I have to.
Time. And this is velocity.
I almost said density. I don't know why.
Totally. Okay.
Okay, so now I have to find the velocity, correct?
Yeah, but first write down what you think is best.
So don't write this, right? The 2, 4, 6, none of that.
If you think it fits best for this graph, then you should. But you should, yeah. Cause scale, you need a scale there.
Does it? So it's just whatever I feel is right, or there's a specific answer to it? Cause like, but will this start at 0? Like right here? Oh wait, will this start at 0?
What's our 0?
The velocity, like 0, 1, 2, 3, 4, 5, 6. Cause it ends at 6, and I can just 0, 1, 2, 3, 4, 5, 6, like that. But no, cause it goes to 8, right?
Yeah, so don't use 1, 2, 3, 4, 5, 6.
If I count by 2s, I might be able to do it.
Mm-hmm.
So do I put the 2 on this, or like 1 up?
What do you mean?
Cause like you know how this is like the 0 right here, right? Do I put the 2 like right here or like right here?
However you feel is best.
Okay. Like that? Would that be fine?
Yes.
Cause I can still all the numbers are perfect, but don't I have to go down? Because of the 12, -12.
Yes.
So
So
-2.
But you're not gonna reach negative 12.
What do you mean? I'm confused.
Like, cause you go up 8 minus 12.
Oh,
Zero.
yeah.
So you're not gonna reach negative 12.
Oh. Yeah, but you just subtract by 12 to get. Oh, I get you. I'm sorry.
Mm.
So you basically do 8 minus 12 to see how many down you go, right?
Well, first do the first part. Do part A.
Okay,
Do the
so
first part of the graph.
2 right here, right?
Mm-hmm.
And then 4. So would you go? Okay, so 4 right here, right?
Mm-hmm.
So 2, 4 right there, right?
No,
Oh.
it's 8 meters. So for 2, you'll go up 8.
Oh. So for every 2 meters, you go up 8.
Just for the first part. For 2, yes.
So there, and then
So you connect it.
yeah, and then you go down 12 though, right?
Yes.
So 2. Wait, go. But how much would be? So it'll be right here, right? For 2. Cause I'm confused. How do you get to? What's the next point? Like
Wait, Nick, no.
side to side.
This is not this. Because this is 4. 1, 2, 3, 4. So go up to 4 right here.
Oh, but it's still on the 8.
Yeah, it's still on the 8.
All right, so that's. Oh, I'm sorry.
Okay. So, be
And then
right
so
here.
the next one would be 6, correct? Because right here. Or
You're
where?
forgetting about this one right here. Don't look at this
Oh
one
yeah,
yet.
my bad. So it starts at 4, and then goes to 6. Yeah, so 6, right?
Yes, but where would it be?
It'd be down. Oh wait. 2.
You go from 8 and you subtract 12 basically.
2, 4, 6, 8, 10, 12. So it'd be like right here,
Negative
which would
4.
be negative 4. Yeah, correct.
Mm-hmm. So right here, connect that right there.
Yeah, and then the next one would be 8, but up 0. So it'd be right here, right?
Yes.
And then you connect it like that.
No.
I thought it was 8 because it ends right here at 8.
Yes, you do end at 8, but this has no movement. It's at 0. So it would just be like that.
Oh, yeah, my bad.
But you
So,
do end at
so
8.
this is just the movement. This is like where how you move it.
Yeah, so 8,
And then minus
negative 12, 0.
Oh, yeah. All right, I get it now.
Mm-hmm. And then this is just telling you like the distance to go. Cause like this one was 0 to 4 for the first one, 0 to 4 right here. This one was 4 to 6, 4 to 6 right here, and then this one was 6 to 8.
All right. Yeah, I got that now.
Okay. Do you feel comfortable enough with me giving? Do you want to take a break real quick?
I want to take
Like a
break.
water break?
I'm okay.
Are you sure?
Mhm.
Bathroom break?
No, I'm okay.
Okay. Okay. I'm gonna give you a couple more problems, and I'm gonna have you solve it by yourself.
Right.
Okay. So let's see here. Like this is gonna be like review of everything, cause you just learned like 2 like
Am I allowed to use this,
parts.
or
Yeah.
do I have to like memorize? Oh, okay. So I can use this.
To help
Can I
you.
get the notes, the other ones? Because this is just on the triangle.
These are the notes, Nick.
Oh, I just flipped it. My bad. All right, thank you.
So I'm gonna give you this graph, and I'm gonna ask you to find average velocity. So find average velocity, displace, and the math model.
In order from that? Or
No, just
just find it.
or just whatever like you think goes first.
Okay.
Okay, so let's see here. So this is a 5, not 3.
Not a 3. Good to know.
Okay. Wait, no, I'm not done. That's only part 1.
Only part 1.
There's so many parts I need to give you.
Looks like you can only fit 3.
What is the best place for me? Okay, so anyways,
Okay.